Hey everybody, coming at you from the deck today. Such a beautiful day. I had to getting ready. We're gonna talk about a special type of functions today. So far we've done linear functions. We did quadratic functions that made the u's, and we found where they cross the x-axis. And now we're going to talk about growth and decay functions. So today is going to be growth. Next Tuesday will be decay. And so these are really cool. These are called exponential functions, and we dabbled in this with a couple things when we talked about things like interest during our financial planning project with percentages. So exponential growth happens when like something happens over and over and over and over, and it's not linear. So instead of being like plus two more, it's like doubles, triples. And so I'm going to show you a couple examples so we can see kind of what that looks like, and then we're going to apply it to situations. And this is one of my favorite things every year because it applies to so much real world stuff. You'll see it in like population growth studies. You see it in a lot of scientific journals about like fish populations, all kinds of financial stuff, growth and decay. But today we're just going to focus on growth. We're going to go a little back and forth. It's all based on percentages, but you know, if it says something like double, we're not thinking percentage necessarily. When something doubles, it's an increase of 100%. But a lot of stuff we're going to look at is based in percentages too. And so we're going to talk about how we set these up as a function, and then how we like make predictions based on that function, okay? So there's going to be two parts. You'll see when you get to your Go formative, I'm having you do 6 problems, but on the part where you answer questions, it's going to look like 12 because there's 2 parts to each one. So you're going to write the function, and then you're going to solve kind of for a variable in the function. So let's take a look. So we're talking exponential growth, and one place I think you might have some experience with this is 6th grade science. You did a bacteria lab, and in that lab you saw how bacteria grew, and you learned things like that bacteria use binary fission. They use binary fission to reproduce. So one splits in half. So at 0 days, let's say you start with 1 bacteria. If they double, one day after there'd be 2 if they double each day. 2 days after there'd be 4. 3 days after there'd be 8. 4 days after there'd be 16. 5 days after there'd be 32, and so on, right? So one thing you might notice, if this was linear, it'd go like 1, 2, 3, 4, 5, 6. It'd be a common difference. There's no common difference here. These have a common factor, right? It's doubling. So instead of like y equals something happening each time plus a starting point, there isn't the same thing happening each time in this way. This would be addition. Repeated addition makes that multiplication. So that's why this is exponential. Now we can get this into an exponential function, and it's always going to look like this. You could say y or f of x. Okay? It's going to be the initial value. So in this case, we're starting with 1 bacteria, and then we're saying that 1 bacteria doubles, so times 2, and it doubles each day. So what this is going to be is this exponent we're going to keep as an x for now. So what this says is the total number of bacteria is equal to the original bacteria doubling each day. And then order of operations is going to make this part happen first, right? How many times is it going to double? And what this will look like on a graph, you can see if I start 1, 2, 2, 4, 3, 8, and then it's going to be off of there, right? So these functions kind of look like this. And how you explain these functions is this one's kind of you would say approaching infinity, and this one's approaching 0. It never quite get to 0 if you went left, which there's no reason to go left. There's not negative time at this point. But this one, you know, it's never going to be a vertical, straight up and down, but, you know, depending how you zoom in and out, it looks like it's going to go straight up because that's how an exponential function is going to look. This one is exponential growth. So again, we're going to go to our function. Total equals original times the growth factor to the exponent of how many times it happens. Okay? So that's like how bacteria will work. Now, you're going to pause the video in a minute. I'm going to ask you a question. Would you rather have, for your birthday, Rich Grammy, let's say, would you rather have 10 mil or a penny that doubles every day for a 31-day month? So which one would you rather have, 10 mil or a penny that doubles every day for a 31-day month? Now, pause the video, make your prediction, and then we're going to get after it. All right, so you might want a calculator to kind of help you with this. So let's look at this penny. So the 10 mil, that's fixed, right? But the penny, we can look at, a pattern of what's happening with that penny. So day 1, it's going to be worth, well, let's do day 0. That penny's worth 1 cent. After 1 day, it's going to be 2 cents. 2 days, 4 cents. 3 days, 8 cents. So, you're not going to want to do that 30 times, right? Because, like, taking a penny and doubling it 30 times is going to be quite a bit of work. And there's a good chance you get off by a day or something, right? So, what I suggest doing is using a function. So, the function of x being the number of times it's going to double, or the total, is going to be our initial value of a penny, and then remember what's happening with that penny? It's doubling, and it's going to double 30 times. So this is our function. Now you can slap this into a calculator much easier than you could go times 2, times 2, times 2, times 2, times 2, times 2, and keep track of it 30 times. And what you're going to notice is, and make sure when you put this in your calculator that you're using, be careful to make sure that the order of operations is going to make that happen first, right? Exponents first. This pumps out, after 30 times of doubling, $10,737,418.24. So I think I would choose, maybe I'd choose this, but then, you could have, and remember, this is going to look something like this. The graph is going to go like something like that. But one thing, you could have snagged this 10 mil, threw it in some Bitcoin and doubled it or something maybe. I don't know. Maybe you want that money early. But at the end, if you just have 10 mil after that many days, or you get the doubling penny, you would have 737,000 more with the doubling penny. So let's look at, this is going to be a little more like what your homework kind of looks like. And so you're going to be given a situation. We need to get that situation into a function and then give an answer. On the Go Formative, make sure you're using things like commas and dollar signs because it's going to grade your work, but you need to type it in right. And if we're talking money, unless directions say otherwise, everything is going to be the nearest penny or the nearest hundredth. So you need to know, you have to look at the thousandth to round to the hundredth. So let's take a look here. And you're going to have your calculator handy. I got mine handy on my phone. I don't have the one I like from school, but we're making the phone work. If you flip your phone horizontal, it'll turn into a scientific calculator for most phones. So remember, my function is going to start with, the first thing is going to be my initial value. And in this case, we're selling Jordans. I asked you, how's business? You'd say booming. You're selling 50 grand. You sold 50 grand Jordans last year, guys. You expect to grow your business, and I'm going to start highlighting the important things, by 5.75% a year. How much will you sell in 10 years then? So we're going to start with our initial value, 50 grand. And what's happening to that 50 grand? 5.75% growth. Now here's one thing you got to remember. No change is 100%, right? Because 100% of 50,000 is 101 times 1. So to show that 5.75% growth, this needs to be my growth factor. That's what I need to multiply by. If I only multiply by 0.0575, that's just going to tell me how much it grew. It's not going to give me my total sales. This one right here is because there's no change times 1. All right, and we saw this earlier with some percentage stuff. And then 10 years. So X up here, that's how many times it's going to happen, right? So I can go to slap my 10 into that X for that X one. So really all this says is I have 50 grand, 5.75% growth for 10 years. I just took my situation and made it into my function. So this could be one part of your homework. For your homework, I'll take the X or the 10 there because you can apply situation. I'm cool with that. So that's one part. The next part is just slapping this into your calculator. Now I've got my calculator here, my phone-ulator. 50,000 times 1.0575 to the 10th. And the to the thing on most calculators is going to look like an x to the y exponent somewhere. And that's going to tell me, and this is how I want it to look in Go Formative. So make sure you're getting your calculator to pump out something that you would type that. So $87,452.81 after 10 years of hustling on those Jordan kicks. And I'm going to imagine Jordans are more expensive now after the Last Dance show. It's pretty tight. Yeah, maybe do some research. Tell me if if Jordans are worth more now because of that. All right, let's look at this. I think I spelled Wakanda wrong. Wakanda. They became known now. Their population's been growing now by 0.4% every 6 months. We want to know how many people there 4 years from now. And we need more. If there were 520,000 people. Okay? So that's important too. So our function, it's going to be initial value, so 520,000 people. And our growth factors, this one's going to be a little tough. To make a percentage in a decimal, remember, move it twice. So it's going to be 1.004. That's a 4% growth factor. Remember, multiplying by 1 is no change. And it's going to happen every 6 months for 4 years. So this is a part that's a little tricky. That means it's going to happen twice a year for 4 years, so 8 times total. So if it happens twice a year for 4 years, that's 8 times total. So this would be part 1, where we get a function, and part 2 is slapping that into a calculator. So in the calculator, I've got 520,000 times 1.004 to the 8th power. And that gives me a new population of 536,874.833. So this can't be my answer, guys, because you can't have part of a person. So we're going to round to the nearest person. That's going to be 536,875 people. And we're always going to use units, right? Math is communication. I'm not sure if you've ever heard me talk about that before. All right, that's a lot of people saying Wakanda forever. But, they're known now if you ever watched the movie, so people are going to be trying to go there, I think. Now we're going to talk about some investments. So you're going to invest money into a guaranteed bond of some sort at 2.75% interest. It's compounded quarterly. How much will your $5,000 be in 8 years? So let's make this function. So we need our initial value, which is $5,000. Our growth rate is going to be 1.0275. Remember, we need that 1. That's no change. Now here's where it gets a little tricky. Quarterly for 8 years. So quarterly means each quarter. So 4 times a year for 8 years. That's going to happen 32 times. So this would be the first part of your homework where you're getting a function to match your situation. Then we're going to slap that in a calculator. And I would suggest practicing slapping these in the calculator right now before you go do the homework. Remember, homeworks, you need to have a passing grade. You can redo it. So just fix mistakes. So after 8 years, this $5,000 would be worth $11,912.11. And this is how I'd want to see it informative. A dollar sign, a comma. Man, what a good investment. Quarterly? Let's go. All right, guys. That's it for today. We'll talk about exponential decay next time. Just make sure you're working hard, hitting me at those office hours, asking good questions. Let me know if you need anything. If you do something after the fact, make sure you email me so I can update Skyward. And, I wish we were together in class, but we got to work with what we got to work with, right? So I hope you're doing well and been missing y'all.